Hello, everyone. I was able to look at some of the ice cube labs that some of you have already done, and I was very impressed with that. Picking some really interesting materials, and many of your predictions are correct. So that's great. Just a reminder that that was all about conduction when we talk about thermal energy. Okay. Today we're going to be moving on to the next two forms of thermal energy, which is convection and radiation. And so let's start with convection. So in your notes, I'd like you to write down the definition of convection here. Convection is the transfer of heat by movement in fluids. Okay, and in fluids, fluid actually means liquids or gases. Okay, anything that takes up the volume and the shape of something, a container, will be considered a fluid, even though that most fluids, or most of the time we think about fluids as liquids, fluids are liquids or gases. So thermal convection is when heat is going through and is transferred through liquids or gases. All right, and with that definition, I want you to put down convection currents. So the way that the convection works is that it goes into a current, just like a river has a current, and you have that movement, that kinetic energy. Heat has a current also, and the current goes in this way. Okay, the heat always rises, and the cool always sinks. Okay, and so that's what we call a convection current. So in your notes, please have the definition of convection and then convection current. If you need to pause this video at any time to write these down, go ahead. Okay. And it's really interesting because there's many different things throughout our life that are affected by convection currents that you might not even realize. Okay, so this example here says the heating and cooling of a room involves convection currents, and I'll show you a picture of that soon. But just you sitting in your house on a winter day, you are experiencing convection firsthand. Okay, so what this looks like is this. Okay, so you see the red arrow is going up, and then the blue arrow is going down. So heat's going to rise, and then the cool air is going to go down. Okay. This is also one of the things that causes wind or local winds or breezes, because the hot air is going up. That allows the cool air from whatever body of water you're in to come in. Okay. A cool way to show you this. This is a demonstration that we would have done in school. This is not our video, but I usually fill up a fish tank full of water, and I have some hot boiling water, and I dye it red. And then we get some cold water that we just take out of the freezer that we've had in there for a little bit, and we're able to see how this convection works firsthand. So when I play this video, I'm going to kind of just fast forward it here. Okay, as soon as this teacher adds the cool water, you can see it instantly wants to sink to the bottom, and the hot water goes in because the fluid flows down, but then right away starts to go up. Okay, and then the current starts working, and it's going to work in a circular motion where you have the cold water coming down, taking the place at the bottom, and then the hot water in the red going up and then to the left here in this video. Okay, now if this were to continue this process, it's going to keep going back and forth and be spinning in a circle. This is what happens in oceans and things too. But some of the things that you're more familiar with is like our house. Okay, when you have your furnace downstairs or any sort of heat source, okay, the heat is going to rise. So if you have a room upstairs, that's going to be the hottest room. And then typically your basement, where the cool air is going to sink, is going to be the colder of the areas. And that's a lot of times why many of our houses have these vents where it's actually cold air going down it. Okay, you might have wondered what that is for and why isn't there hot air coming out of that? Because that is taking the cold air and allowing for this convection current to constantly be working. Okay, another couple examples that I have for you. One thing would be like your oven or an air fryer. These are kind of a new way to cook. This is a air fryer just constantly allows for this convection current to be happening really rapidly, and that's why it cooks things so quickly. Your oven does it a little bit slowly, where you have that hot air and it's just continuing to keep circulate as you go. And then in one of the most interesting ways I think that you see convection currents is actually why our plates move, why we have earthquakes and volcanoes and things like that. When we have the Earth's mantle, Okay, as you get closer to the center of the Earth, it's going to get much hotter. At the crust or the surface of the Earth, it's going to get cooler. So inside our Earth, we have constant convection currents that move very slowly because this type of material that the mantle is made out of is much thicker. And so you're going to have the hot from the core moving up, and then the cool from the surface moving down, and that's going to create these wheels, okay, these circles of convection currents that allow for the different for plate tectonics to be moving. Okay, and remember they move in 3 different ways and things too. Okay, so that's convection. The second type, the last type that we're going to talk about today is radiation. Okay, this one's the hardest to really grasp. Conduction was when you have a direct contact with it, right? When you put the ice cubes on whatever surfaces that you put them on. Convection is that moving through fluids. Radiation is a little different, okay? And the notes here is radiation is a method of heat that does not rely on any contact between things. So basically, there's no contact through fluids, no motion through liquids, gases, or indirect contact. Okay, so the best way to explain this is when we talked earlier in the year about the electromagnetic spectrum, and we have these different waves that we can't see. One of those waves that we were talking about is within this radiation, okay, is the heat waves. And so the best example for this is if you're sitting out on a sunny day and you're feeling the heat, or whenever you're close to a fire and you're putting your hands up and you can feel that heat. You're not touching it, okay? It's not moving through a liquid or gas. It's not like you're putting your hand in the water or anything near it, but you just put your hands close to it and you can feel the heat radiating off of whatever it is, the heat source that you're using. Okay. And so along with that definition, it says the energy is transferred through electromagnetic waves. So not waves that you see. Okay. You can feel them, but you don't see them typically. Okay. Sometimes you can definitely see the heat off of like some asphalt or something in the summertime when the sun's shining really hot on it, and you can see that radiation a little bit coming off of that. Okay. And then a little bit with that, okay, so when the molecules in your skin absorb the energy, the average kinetic energy, so the movement of those molecules, and they allow for your skin to heat up and be moving faster too, and that's really what causes your skin to be burnt. Okay, so that's why we wear sunscreen and things, even though we don't necessarily know that we're going to be getting burnt. There's this heat radiation constantly working. So to kind of quiz you here a little bit, a couple examples. So if people are sitting around a campfire and they're able to feel the heat from the fire, how can they feel it without touching it? What of the 3 forms of thermal energy would that be? Conduction, convection, or radiation? Okay. And hopefully, after going through the notes, you could figure out that that's actually radiation, right? They're not touching the fire. They're sitting around it, and they feel that heat coming off of it, not moving through anything. The next example, Bill stands in a swimming pool and notices that the water around his feet is a lot cooler than near the surface. Okay, this happens a lot if you're swimming in a lake or any type of natural body of water where the sun's going to hit it, or even in a pool, it happens. But the process then, okay, if it's cool at the bottom, it's going through a fluid, okay, it's hot at the top, and that's because of convection, because of that convection currents of the heat rising and the cool sinking. And then one other thing that I just wanted to talk about is this is an important concept because many of the different jobs that you might be doing when you get older are going to deal with the different types of thermal energy. So we have things like all the roads in Wisconsin and how things change because of the differences in temperature of things heating up and then cooling down. It says adding heat causes materials to expand. Okay, so you notice in bridges and when we build roads, we're going to have things expanding. And then when they get cold, okay, they're going to shrink and condense. And so therefore, whenever we build things and have things certain ways, in Wisconsin, we have to be thinking about how things are going to react when they are hot and how things are going to react when they are cool. So a couple examples like train rails. Okay, we have to make sure that we have those where they are able to move a little bit from left to right, and so we don't nail them down exactly because they need to expand and then condense too. And one of the other examples is some people don't understand why our electrical wires not hung so tightly. Why do we have them drooping down? And it's just because of exactly this. In the wintertime when it's freezing, they're going to shrink and then they're going to expand. And so if we had them completely tight, they would then break and things would be cause issues. So today at 11 o'clock, Mrs. Schutz and I are going to be doing an example of convection for you, a demonstration. So if you can please get on and you simply just have to watch that and take notes for your assignment today. And to just kind of review, know radiation, conduction, and convection. Understand a little bit about how they work. In future science classes, you're going to be talking about these a little bit more, maybe doing some equation, chemistry type things too that deals with thermal energy. But these are just also good to know just for your daily life and understanding the different types of heat energy to keep yourself safe and energy efficient in your house. So thank you all for listening. I hope you all join today at 11 o'clock. See you soon.